Okay, we're continuing on the back side, number 15. So on number 15, we have an antenna that's atop the roof of a 100-foot tall building. So there's a 100 feet, and 10 feet from the edge. So from a point 50 feet from the base of the building, the angle from the ground level to the top of the antenna is 66 degrees, so it's right here. Find the value of x, which is just this antenna here itself, and we want to round this to the nearest foot, and this is not drawn to scale, of course. So let's go ahead and first start off with coming up with a game plan. Now I went ahead and redrew this so I can kind of draw on top of it. That's going to help me out, at least in figuring out the answer. So first of all, what I'm going to do is I'm going to go ahead and say, okay, well, this is just part of this full side. So actually, if we take the full side, and I'll just go ahead and extend that down, if we find out what this full length is right now, then I can go ahead and subtract out just this piece, which is 100, and I'll know what's left over. So that's my game plan. This is your 90 degrees. This side is the side I'm going to solve for. And then this right here, 66 degrees. Now the only thing is that this doesn't go 50 all the way to the end. So I need to know what this is. Now keep in mind it's from here to the edge is 10. So this all has a length of 60 feet. All right, let's go ahead and use some trigonometry because I have an angle measure and I have a side length and I need to find the other side length. So I'm going to go ahead and write SOHCAHTOA here real quick. And looking at this, oh, there's the light again. I have the side, well, let's look at this here first. This is my reference angle. So this side is considered my adjacent side, and this side all the way across is considered my opposite side. So which one has O and A? It happens to be tangent. So I'm going to go ahead and use tangent to solve for this. So tangent of, and I want to use my reference angle, 66 degrees equals O over A. O is what I'm trying to find, but I don't like to put O because it looks like a 0. So I'm going to write H for kind of like the height of the whole thing. Divided by adjacent, which I know is 60. All right, let's go ahead and cross multiply. So I'm going to go ahead and put this over 1. 1 times H is H. 60 times tangent of 66 is 60 tangent of 66 degrees. These don't multiply together. This is a side length, and that's an angle measure. So we're going to go ahead and just plug that into our calculator here. So we're going to put in 60 tangent of 66. And that gets me approximately 130, rounding off to the nearest foot, is 135 feet. So H is approximately 135 feet. Now that's not the answer because it's asking us just for X, which is from here to here, and I found the full length. Now since this is 100, I'm going to go ahead and take the 100 away from this to see what's left over. So subtracting 100 will get you 35 feet. So the height of this antenna is about 35 feet. All right, let's go ahead and take a look at this next one. So this next one is giving us coordinates of triangle ABC, and we have to take these coordinates, the original ABC, with the coordinates of the image and find out what's the scale factor of this. So since we know that there's some sort of scale factor, I'm going to assume that it should be the same no matter which two coordinates I use. For this case, I'm going to go ahead and use the coordinates A and B. So A is 1, 2, and B is 1, 5. So if I were to plot the points, I'm trying to figure out how far is the distance from A to B. Well, if you notice, I have my numbers here. If I was at 2 and I'm now at 5, that's a distance of 3. So AB has a distance or a length of 3. Now I'm going to do the same thing, but this time I'm going to use my image. So I have A prime, that's 3, 6, and then I have B prime, which is 3, 15. So for this image, I'm also going to look at the distance between these two. So if I was at 6 and now I'm at 15, the length from A to B is now a distance of 9. 15 minus 6, 9, 5 minus 2 is 3. Now if you remember how to find the scale factor, it's taking your image and dividing it by your original length. Now this is my original and this is my image. So it's 9 over 3, which gets me 3. So this has a scale factor of 3. Okay, now we're going to find the coordinates of point P that divides the directed line segment from A to B in this given ratio. Okay, so let's go ahead and first figure out what the ratio is. So to find the ratio, you do 3 divided by not 6, but 3 plus the 6. So that's 3 over 9, which is 1/3. So we want to find the third of the way between A and B and find that coordinate. All right, so let's go ahead and do that. So first of all, I'm going to go ahead and use my x value so I can solve for what the x value is going to be. Well, first of all, let's go ahead and figure out what is the distance for the x's. So I'm going to go ahead and take 16 and I'm going to subtract the -2. So 16 minus a negative is adding, and I'm going to take a third of this, so I'm going to multiply it by 1/3 to see how much I have left. And then that will tell me how far it is from A, but you're going to have to add on the original x value to see where does it land on the axes. So we have -2 plus 1/3 times 16 plus 2 is 18. And 1/3 times 18 is 6, which gets you a coordinate of 4 for the x value. All right, but we're not done because we actually have to still find the coordinate that's the y value. So I'm going to go ahead and now do the same thing with y. So I need to find how far it is from A to B with my y values. So I'm going to go ahead and take 12 and subtract the 3. And that will be a value that I'm going to take 1/3 of. That'll give me the actual length, how far it is from the y. So I'm going to have to add on the original y to see where it moves to. So 3 plus 1/3 of 9. And 1/3 of 9 is 3. 3 plus 3 is 6. So the coordinate is 4, 6. All right, let's go ahead and take a look at number 18. So 18 says that given the height of an equilateral triangle is 5√3, find the area of the triangle. So to find first we have to actually solve for the actual base. So if I have my triangle right here that's equilateral, all sides are equal, and I know my height is 5√3 meters, and I have to find the actual area. The area formula for a triangle is 1/2 base times height. All right, so I already have the height. I need the base. But if you remember that the special triangle is one of the equilateral triangles split, because remember every corner of an equilateral triangle is 60 degrees. And then this is 60 together, but split in half is 30. So if I know that this is 5√3, and I find what this side of this little special triangle is, I can basically double it to find the full length. So remember the side lengths for this is n, this side is 2n, and this side is n root 3. Well, if I know the side is n root 3, then I know n is 5. So if this length is 5, that means this side is 5 for a total of 10. All right, so now we're ready to find the area. So the area equals 1/2 base, which is 10, times the height, which is 5 root 3. So we have 1/2 times 10 is 5, and 5 times 5 is 25 root 3. And this is in meters, so it's meters squared. Remember that area is square units. All right. Number 19. What is angle F, given that we have a right triangle EFG where the right angle is at E and EF is 12 and EG is 5. So let's draw ourselves a picture. We're drawing something out. It helps us give a visual. We know the right angle is at E. So F and G, it doesn't really matter. So I'm going to go ahead and F that, and then G is that. Okay, so we have our triangle. Now let's go ahead and put our side lengths. So EF is 12 and EG is 5. So let's go ahead and find out what is angle F. So this is the angle I'm trying to solve for. We're going to use trigonometry. If you know two side lengths, you can find an angle. Or you can find a side length if you know the angle measure and just one side of a right triangle. So let's go ahead and label what this is. If angle F is my reference angle, this is opposite. And this side is the adjacent side. So I want to use tangent, TOA. So tangent angle F equals opposite 5 over the adjacent side, which is 12. And then to solve for F, we need to make this tangent go away by taking the inverse. So F equals tangent inverse of 5 over 12. So we're going to need our calculators to plug that in. Make sure you're in degree mode. So hit second tangent and then 5 divided by 12, which is approximately 22.62 degrees. All right, let's go ahead and go to number 20. So here we have a triangle that we are going to do a few things with. And so looking at this triangle right here, we're asking ourselves, can you verify that this triangle, and I'll draw, oops, that wasn't a very good job, let's go. So we have E, F, G, and G, H, and I. And we know that this is 90 degrees. And we know that this side is 52, 60, and 80 meters. All right, so looking at this, can we tell if they are, or verify if they are similar? And yes, we can. If I notice, I have one set of angles here, and I actually have one more angle. That is the vertical angles. So because, now let's say, can you verify? Yes, because vertical angles are congruent. And I'll abbreviate congruency there. So give the similarity statement. So here's my similarity statement. We have to make sure we put it in the right order. So triangle, and it doesn't matter which order, EFG, let's say EFG is similar to triangle, and it kind of has it right here for us. But no marks, right angle, 1 mark. No marks, right angle, 1 mark. That's the order. And the reason why is by angle, angle, similarity. We have 2 angles, angle, angle. Now we have to solve for angle, or solve for side D. Now side D is this side right here. So we can set up a proportion to solve for it. So to solve for it, I'm going to go ahead and set up a proportion. D over 80 equals 52 over 60. All right, I'm going to go ahead and cross multiply. So D times 60 is 60D equals, and then 80 times 52 is 4,160. Divide both sides by 60, and we get a mixed number here. It doesn't go in evenly. So it's 69 1/3. Okay, let's go ahead and do 21. So 21 is another one of those triangles that are solving for the side lengths. And if you take a look at number 21, I'm going to basically redraw this, but I'm going to draw it all in the same orientation. So I'm going to have my big triangle, my medium triangle, and my little triangle. Let's start off with a big triangle. So with the big triangle, I have my short side. So in this big triangle, I have this length as the hypotenuse, this is the longer, and that's the shorter, so that's A. The medium is C, and the hypotenuse is B with the 24. So I'm going to write B plus 24. For the medium, I'm going to go ahead and cover this one up right here. We're just looking at this triangle here. So we have the length that is the shorter length out of this is the 32. The longer length is B, and the hypotenuse is C. And then finally for this small triangle, which one's the shortest side? The 24. The longer leg is 32, and the hypotenuse, which is across from this 90, is A. So now that I have this set up, I can go ahead and solve for A, B, and C. So let's start off with solving for A, and we'll see if it's possible. So I have an A here and I have an A here. But if you try to line up what goes together, A goes with 24, and this A goes with B plus 24. You can't have A and B in the same equation and in order to solve for 1. So you need only A in this ratio. So let's see if we have another option. Well, I do notice I have 2 sides of the triangle. I can actually find the third side by just using Pythagorean theorem here. Okay, so we have 24 squared plus 32 squared equals A squared. And 24 squared is 576 plus 32 squared, which is 1024. And adding these together gets you 1600. Ooh, this could have been a Pythagorean triple that I did instead. All right, so square root, this would have been 40 for A. Yeah, if I would have looked at this a little more closely, I noticed that 8 can go into 24 and 32. So I'm just going to show you on the side here. So if I had this side divided by 8, I would have gotten a 4. If I divide this side by 8, I would have had a 3. Guess what? This would have been a 5. And if I multiply 5 times 8, there's my 40. Which is fine, either way. Okay, so I found A. A is 40. Now, if it helps you, you can actually write down 40 here and 40 here. That might help you when you're solving for one of the other sides. All right, let's solve for B. I have a B here, and I have a B here. Now that lines up with the C, and these are not going to help me out. So I'm going to go ahead and look on to this side that I have most of the values. So if you look at this, I have B that goes with 32. Let me get this to light up again. There we go. So B goes with the 32, and the 32 goes with the 24. So I'm going to use that to solve for B. So B over 32 equals 32 over 24. And if you cross multiply, B times 24, and 32 times 32 is 1024. And if I divide both sides by 24, you get 40, well, it's 42 and 2/3. Okay, so this is B. All right, and now we have to find C. So I have C here, and I have C here. So there's a couple of ways you could do this. I could take this and say, okay, 32, I know B is 42 and 2/3, and then solve C by using the Pythagorean theorem. That's one way. Let's see, I could also use C with 32 and 40 with 24 as well. Since I don't like fractions, I'm going to go this route instead, okay, because there's multiple ways to do these problems. All right, so solve for C. I'm going to go ahead and use C over 32, setting a proportion, equals 40 over 24. And you could reduce also before you cross multiply, but I'm going to go ahead and just cross multiply. So we have 24C equals 32 times 40, which is 1280. Divide both sides by 24. And we get another fraction, which is 53 and 1/3. All right, take a look at this one. So we have a man that's standing 50 feet from the base of a monument, holding his camera 3 feet off the ground. He measures the angle of elevation to the top of the monument as 49 degrees from his camera. How tall is the monument? All right, well, let's go ahead and draw this out. So we have a man. He's holding a camera. And he is standing 50 feet from the base. So here's the base of whatever monument. Just figure. Okay. And so this is 50 feet from the monument. And then he is measuring the angle of elevation to the top of the monument as 49 from his camera. So if this is his camera, and he's looking at the top of the monument, he's saying this is 49 degrees. Okay. And then it says, how tall is this whole monument? We want to know this full length. Well, I forgot to put in the 3 feet off the ground for this right here. This is 3 feet for the camera being off the ground. Okay, so my suggestion, if we're trying to tackle a plan here, is we know this length down here is 50 feet. These should be the same. If I solve for this side, make that, let's say, x, then all I have to do is add on the 3 feet below from here, and we'll have the full length of this monument. So, angle and a side length. That's trigonometry. So let's go ahead and write down what they are. So all the way across here is considered the opposite. This is considered the adjacent side. And so we have tangent here. O and A is tangent. Tangent of 49 degrees equals opposite over adjacent. Go ahead and cross multiply. So we have x equals 50 tangent, let me move this up, 50 tangent of 49 degrees. Let's go ahead and put that into the calculator. So we have 50 tangent of 49, and that equals about, and to say to round off to, no. So we're going to go ahead and say x is approximately 57.52. Okay, 57.52. And that's in feet. Now that's not the answer because the answer is the whole length, and we only found x, which is this part right here. So in order to find the full length from here to here, we're going to have to tack on the 3 feet that is from the end. So I'm going to go ahead and add 3 feet to this to get a total of 60.52 feet as the height. All right, and we have 2 more. So I'm going to go ahead and just put this onto this same video here. So number 23. Says in the figure below, the 2 triangles are similar. We're going to find M and N. So we have kind of a small and a large triangle. We have 9 degrees. We know this is 8. Here's M. And we know this is 5.5, 6, and N. All right, so there's a lot of different ways to do this problem. But since I know that these triangles are similar, I can set up a proportion. So if you take a look, you can find the ratio of the side length. Oh, I forgot to write 12 here. A ratio of the side lengths. 6 goes with 12 and N goes with 8. So you can set that up. So 6 over 12 equals N over 8. And you can cross multiply. 12 times N, 12N. And then 6 times 8, 48. Dividing both sides by 12 gets you N as 4. So we know N is 4. And then let's solve for M. Now M is inside, so you can use the side lengths 6 and 12 again with the M. So it's like pretending that this triangle is not there. We're just using the triangle that's on the top left and the bottom right. Okay, so let's go ahead and set that one up. So we have 6 over 12 equals 5.5 over M. And then cross multiply. 6 times N is 6M equals 12 times 5.5 is 66. And then dividing by 6 gets you M equals 11. Now I know I went through this whole thing, but for me, I noticed that if these are similar and it goes from 6 to 12, it just doubled in size, right? Or you could say 12 is half its size. So if it goes from 12, half is 6, 8, half of that is 4. That should make sense. And if you go from 6 doubling to 12, doubling 5.5 to M makes 11. So that's another way you can look at it. All right, and the last one. So number 24, we have parallel lines here, which means these are split proportionally. So all we're doing is taking 12 divided by the 3 equals 2x minus 3 over the x minus 5. And then we're going to cross multiply. So 12 times the x minus 5 equals 3 times the 2x minus 3. Distribute. 12x minus 60 equals 6x minus 9. Let's bring the 6x to the other side, and let's add 60 to the other side. So we have 6x cancels, and we get 51. Divide both sides by 6, and we get a total of, let's see, 51 divided by 6 is 8.5. And that's it.